Cool. 11:40 Stone Game 2. Alex and Lee continue. Alex and Lee continue their games with piles of stone. There are piles of stone arranged in a row. Each pile has a positive integer number of stones piles sub I. The objective of the game is to end with the most stones. Alex and Lee take turns, with Alex starting first. Initially, M equals 1. On each turn, a player can take all the stones in the first X remaining pile, where 1 is less than or equal to X, which is less than or equal to 2 and M, where M is equal to max of M and X. Then M is equal to, what does that mean? Okay, the game continues until all the stones have been taken. Assuming Alex and Lee plays optimally, return the maximum number of stones Alex can get. Okay, let's read the example for a second. Alex can take 1 pound in the beginning, Lee takes 2 pounds, then Alex takes 2 pounds again. Okay, so Alex took the 2, Alex took 7 and 9, and then what? Oh, Alex takes 1, well, the first one, which is a 2. Lee takes 2 pounds, and Alex takes 2 pounds again. If Alex takes 2 in the beginning, then Lee can take all 3. Okay, that seems. Wait a minute. Wait. What is M? Is M in the thing? No? Okay. Initially M is 1, okay. And you could take. Okay. And then M either goes up by. Okay, it doesn't have to go up actually, but so on the first turn, you could take 1 or 2 piles, and then the second turn you could take all the way up from whatever that is times 2. Okay. Hmm. Let me think about how I want to solve this. So there's a game theory thing to it, but maximum stone action game. And each power is up to 1,000. Is that helpful? So that's 10,000. But yeah, I mean, so my first intuition is that you think of it in terms of dynamic programming, then your states are, and this is just like first impression. I haven't really done the math or anything, but you have M. And then the position of the pile, right? So, and then, so this is, if these are the number of states, M can be probably at most 50. I say this because once M is 50, or maybe even a little bit less. So I guess like probably M is say 33 or so, because once someone took 33 piles, and it's not quite right. There's like some summation in there, but assuming, let's say you could take 33 on the first turn, then the second player would just take all of them, right? So there's no like you could just greedy that way. So let's say M could be at most 33 or so. So 33-ish times position and number of piles, so that 100, so that equals 3,300. And then maybe you could do something with 10,000. Let's leave that out for now. I don't think we could use that yet, maybe. Okay, what can we do with this? So since I suspect this is a dynamic program problem. Then the next question for you to ask yourself is, well, what are the subproblems? What are the some problems given the initial state that we can do, right? So what is f of m equals 1, position, which like maybe let's call x is equal to 0, right? In this case, you can take either so yeah. So the states, so each state would then probably just contains each state would just contain the difference between my score and the opponent's score. So that would be a dynamic subproblem, I think. Yeah, maybe that's enough to be okay. And what you store in the array is just the delta between your score and their score, and then maximize it, and then you maximize that all the time. So okay, let's pretend I'm happy with that. And since powers, I guess this is where it comes in, is since powers could be 10,000 and you only have 100 piles, so that's what, a million? Yeah, so that's a million. So then we can use, that's just to kind of use as allow us to kind of gauge a negative infinity as a worst case thing, but it'll come up. Cool. Yeah. Let me try that out. What's M? Yeah, well, let's go allocate 100, say. This is max M. So, okay. Probably even. Let's just do 100. Why think about it? And then max powers is 100 also. So okay. So in my previous life, I've done a lot of Go, so sometimes I don't end my statements in semicolons. So yeah, luckily it doesn't indent, so it tells me that in a way. Okay. And we actually want this to be, oops, definity, like negative, and that's where the million comes from. And then just I guess M is 1 and first position. Yep. You could do better. It's actually negative infinity. It is a terrible naming, actually, maybe. But okay. So given M, we have a couple of decisions to make, right? So we could take from, I guess you have to take from one power at least, right? Okay. Yeah. So I equal to 1, I to M times 2. And in theory, if you really want to be performant, you cache that M times 2, but I'm lazy. Okay. And then again, that's negative infinity. Take I, and then x plus 1 plus so you get the score of this plus, what is it? Oh, piles of I? Nope. Piles of x. And then I'll just have the base case, which is when x is equal to n1. Yeah, I guess this should just return 0. Just no, well, actually, we want this to be the last n, not n minus 1. Okay. Well, let's give it a whirl. Oh man, that's not what I was hoping for. But oh, why did I do that? That doesn't make sense. Of course, that's gonna be true. Okay, so that's not so good, but at least it's doing something. Maybe there's an off by one somewhere, but oh, this is wrong. I need the sum of this actually. Okay, because you're not just taking the x power, you're taking the wait, what am I doing? Oh yeah, because yeah, I'm just doing the math as if you're taking one power, but you actually want the summation of all these things all together. Okay. Equals p of x. Plus I. Yeah, it's phrased in a weird way, but it should be okay. I guess it doesn't really matter what it is. But now this is x plus I instead, because now you're taking a of them. Now, okay, now we could change it to this. Oh man, yeah, I did make an off by one somewhere. I mean this. I mean, we only changed this, so this is probably causing issues. Let's just take a look. We don't really call much otherwise. Okay. This should just return 0, right? Oh, okay, fine. I mean, okay. Alright, because this was causing issues, I guess. Well, something is getting a Amazon, that looks right. -6. Man, everything always feels so good until I actually code it. But well, let's check these base cases. 138, is that right? That doesn't seem right. There's some weird double negative things here. Yeah, so this is pretty well. I thought the subtraction would handle it, but am I? Oh no, that's right, because you just take both powers if you're given the chance. Okay, and m is equal to 1. Okay, that's fine. That's fair. That should be 13 minus 9. Wait, expect is 13. Why? Can I just read the question? Oh man, I did misread the question. Okay. Okay. Well, I'll have to give me a second to refresh. Looks like I solved the wrong problem again. Okay. I was wondering why these things don't make sense. Okay. Yeah. So what I did, and usually how that's where in a weird way sometimes having experience kind of gets you, because generally I had to. I mean, I know I read this problem, but generally how these game theory problems is that you're trying to maximize the delta of the two numbers. So what I was doing and what this code does is it solves for the most number of stones that Alex has, minus the number of stones that Lee can have, where the question is just the maximum number of stones that Alex can get. Which yeah, I mean we could still do it this way, but we have to kind of modify this. Not to think about how to modify this. Oh, dang it. Okay. I mean, which is to me, but maybe that's why it's only a medium. I thought that was a little bit hard for a medium. Maybe not that much even, but it still requires a couple of other knobs. Okay, let me think then. Because I guess it also depends on what Lee means optimally. Okay, actually, that's not so bad. Because, okay, so I think we still mostly have it. Maybe it's still even the same problem. Because now, you know the delta, so you could just do the math, right? So, for example, so maybe it's actually the same problem. Maybe I spoke too soon. Um, so and that's delta if you could do, you know, so, okay. And now you just calculate the sum of all the piles. Nope. Still misread the problem though. Gotta be better about reading. And then now you have this thing where, was it x minus y equals delta, x plus y is equal to sum, right? So, so then what is x? Well, 2x is equal to delta plus sum, so we turn delta plus sum. Is that right? Is that right? Oh, did I not do it? Seems a little weird, actually, maybe. This assumes x is greater than y, so they may be a little bit. No, actually, maybe not. It doesn't really assume anything. Oh, I didn't divide it by 2. Man. Cool. What's the banana? Not sure what that means. Oh, I guess I should have tested this other thing first. But it's still unfortunate that it actually doesn't work. Yeah, okay, it works for that one. So, oops, no peek. Okay. Why is this wrong then? Oops. Maybe it is off by 1. It's always off by 1. Man, the problem with this is now it's kind of tricky to debug. Because what do I make sense of this? How do I... is this right? It should be right. This folder, I mean. Okay. This might be a tricky one to debug. Maybe I need some pen and paper, unlike last time. Or just something silly, to be honest, but that's how I feel. But, oh wait, okay, I'm going to misread this again. So, actually, M doesn't go down, so okay, so I think I could fix that. That's, because here, we assume that the new M is based off the last M, which is kind of true, but yeah, so we do a okay, so I think okay. If that's the reason, then that's great. Got my fingers crossed, because otherwise I might have to actually dig deep. Okay. Yeah, still bad at reading the. Okay, well, let's submit before. Okay, cool. Okay. Um, I mean, there's a few lessons to be learned from here. One is, when you interview, make sure that you're in the right state of mind, and there's a lot of preparations that and maybe even meditation to make sure that you read the prompts correctly and stuff like that. Or like, I think one thing that is true is that when you're conversing with another person, with the interviewer, hopefully he or she will kind of push you into the right way and and be like, hey, no, you're actually missing. I mean, because I guess most of what I did was silly mistakes, but still kind of, I don't know, a little bit of a mess. But as long as you kind of keep at it, it should be okay. How long did I take on that one? A little bit less than half an hour, so probably a little bit longer than I should have. Added like 8 minutes or so because of silly mistakes. But I think, yeah. But yeah, just make sure you kind of keep grinding and make sure you know, uh, uh, don't beat up yourself before doing it. Something that I kind of fall into a lot. But yeah, so overall, as an interviewee, so that's what I would comment on. There are definitely silly mistakes and something that I need to just be more focused on and kind of really understand every part of this. And luckily for me, like I only misread it a little bit this time. There are definitely times in the past where I misread the prompt by a lot, and I think some of that is, I'm talking to a webcam, right? So I think in general, when I am in person doing interviews, I will ask for clarification and make sure that my understanding is their understanding. And also, I'm kind of a little bit rushing it, not necessarily rushing it, but not pacing myself the way that I would in an interview. You have an hour or so make sure don't necessarily have to jump into code, but just take care of yourself. Don't waste too much time either. But so it's always a tough balance, and that's why we practice. But yeah, I think in terms of a problem, I want to say this is a relatively straightforward coding. Uh, uh, um, this is a straightforward dynamic programming problem or memorization problem. And the first thing, as I mentioned earlier, you just have to kind of figure out what the sub problems are, and then kind of branch off from there, and it relies on kind of like having a substructure that is still going to be optimal. So in this case, we get that here. Yeah. As an interviewer, I don't know if I like this problem. I think some of that if you've kind of been in this channel before, you know that I actually like composite type problems where you need to break a problem down into a couple components and then put them together in a cool way to kind of solve the problem. And those are the problems that I like. And you could kind of say that in this case, in that is game theory and dynamic programming. That said, there is maybe a lot of the game theory problems are dynamic programming problems, at least the ones that are that you can solve within good time constraints. Either that or it's like some really simple code form for loop or something like that. But and I think like I don't know. I mean, I think as an interviewer, I could maybe coach someone through this problem if they didn't already know how to structure code based on game theory. But that would like just waste 20 minutes or maybe less, maybe, but sometimes more. I don't want one to have a problem, which, well, one is so like, you know, the people who already know how to do this, they would have a 20-minute leg up on someone who doesn't. So that seems like a little unfair for game. I mean, game theory is just like a little bit removed from what I would be asking for anyway. And yeah, I mean, I think I mean, I actually am a big fan of math and game theory, but I don't think I would ask someone like this as a game, as an interview problem. I mean, at the core of it, the dynamic programming or memorization is pretty straightforward, and in that sense, like if that's and like if I'm not testing the game theory, then I'm testing the coding up of the dynamic programming. And in that case, like there are like a million other problems I can do, right? If you're just going to have one component to an interview. So for that reason, I mean I like this problem as a problem solver, but but I would probably never ask as an interview, and it's just a little too, I don't know. It requires game theory assumptions that I have building in, and maybe I could kind of get into that a little bit another time because I think I looking back in the beginning of this stream for this problem, I probably hand waved over it a little bit, assuming yeah, you know what the things are, but yeah, but this is basically a min max problem, and everything follows from that, and you could kind of look it up